Hi everyone, welcome to the talk. My name is Xuhai. You can also call me Orson. Today, it's my great pleasure to introduce HulaMove, a novel interaction technique that gets inspired from the hula hoop and leverage the voluntary movement of reduced waste as a new eyes-free and hands-free input methods. Hey, where are you going? Alright, I will see you in the slides. People move their waist a lot in their daily lives. Not only just for playing hula hoop, the waist is also one of the most important parts of the human body to enable tons of daily behaviors, such as walking, running, and heavy lifting. However, in the on-body interaction domain, a large number of techniques have been proposed for hands, arms, feet, and even the head, but not for the waist. It has been mostly used in a passive way for tasks such as activity recognition and health monitoring. But there is no existing actively controlled interaction method for the waist. And here comes HulaMove, a novel interaction technique that leverages the active waist movement as an input method. It can be useful in both physical and virtual worlds. In the real-world scenarios, it can serve as a convenient input channel in situations where users' hands or eyes are busy. In the virtual world, using the waist for interaction can establish a stronger connection between users' physical body and the virtual world, thus augmenting immersive user experience. We investigate the most common two fundamental movements of the waist, shifting and rotation. Knowing how well users can control waist movement is fundamental for waist interaction design. Therefore, we first conducted a user study with a waist-controlled target acquisition task to evaluate users' waist control ability. We compared different number of directions. For shifting, considering that waist can be shifted towards left, right, forward, and backward in general, we compare 4, 8, 12, and 16 directions. Similarly, for rotation, we compare 2, 4, 6, and 8 directions since the waist can rotate either clockwise or counterclockwise. We also compared 3 confirmation techniques and 2 visual feedback conditions. We measured the success rate, completion time, and the number of border crossing of these conditions. Our results show that users can easily distinguish 8 shifting directions and 2 rotation directions, and that quick return outperforms other confirmation technique. Based on the results of the first study, we developed the design space of HulaMove that can be easily performed and socially appropriate, leading to 8 waist gestures. We removed shifting forward and shifting backward gestures as they are considered as socially awkward. Then, we implemented a real-time system using commodity IMU on the smartphone for gesture detection and recognition. Users can casually put a smartphone into a pocket near the waist. They go through a simple calibration stage by performing 1 time shifting right and left and 1 time rotating clockwise and counterclockwise. The system can dynamically adapt to its position and transform the IMU signals to be aligned with human body coordination. Then, a gesture detection classifier is applied to the transformed signals using a sliding window to detect waist gestures. Once a gesture is captured, our system uses a hierarchical machine learning model to successfully recognize 8 waist gestures at an accuracy of 97.5%. Moreover, our model is also robust to the noise in daily routines. Based on the measure of 2 hours daily IMU signal, the model's false positive rate is as low as 0.1%. Finally, we ran a usability study under 2 scenarios. A real-life scenario that simulated daily working conditions when users' hands and eyes were busy, and a VR scenario where users play an immersive game with HulaMove. Our results revealed that the waist interaction only needed less than 60% of the interaction time compared to the touchscreen interactions in real-life settings, and that using waist in VR significantly increased the sense of presence. Overall, HulaMove can provide an additional input channel when users' hands or eyes are busy, accelerate users' daily operations, and augment immersive experience in AR and VR. And that's it. Thank you all for your attention. Hope everyone stays safe and healthy around the world. I'm happy to answer any questions.